All right, lesson 721, how does rate change? Today, we're going to calculate average rate of change using slope. So y2 minus y1 over x2 minus x1. As you study rates of change in this lesson and throughout this chapter, be sure to show all your work. So 68, a shuttle mission lifts off from NASA, Cape Canaveral. Mission Control in Houston was receiving the data. So we have this data, right, it's in this table. Calculate the rocket's average velocity for the given time intervals. Begin each calculation with delta A, that's change in altitude. Delta means change in, over delta T, which is change in time. So we got from 3 to 21. So we're gonna do 21 minus 3, that's our times. And then if we go look at our data, our altitude here is 4533 minus then our altitude at 3 seconds is 70. So when we do this math, right, so what we're going to do is we're going to take 4533, subtract 70, right, so we should get 4463 over 18. And this is approximately like 13.7-ish, right? Okay, so now we'll do it from 3 to 18. So we'll do 18 minus 3. So again, 3 is 70. 18 now is 3,200. So we'll do 3,200 minus 70, which is 3130 over 15. And that's about, 208.6 repeating. Sorry, I didn't do that other one right. 4463 divided by 18 is, let me fix this one. 247.9. And this is feet per second, guys. We're talking about altitude, feet per second, right? So feet in altitude, time is in seconds, so feet per second, that's our velocity or our rate. Okay, so let's go the next one. We have 15 minus 3. So again, 3 is 70, 15 is 2131. So we'll do 2131 minus 70. We'll get 2061 over 12. And that's 171.75 feet per second. All right, now we're gonna do 12. So 12 minus 3. 12 is 1306. So again, 1306 minus 70. Over 9. So we'll divide that by 9. 137.3 feet per second. Now we're down to 9. So 9 minus 3 and 70 is 3. So 9 is 701. .631 over 6. That's 105.167 feet per second. And then the last one here, we'll go 3 to 6. So this is 297 minus 70. That's 227 over 3. And that would be 75.6 feet per second. Okay, so again, you're just calculating slope over and over, right? Or average rate of change in this case. So 69, we have a weather balloon. And so we have air pressure, dew point, and it's radio in this back. So we have time, the altitude of balloon, the air pressure, the temperature in Celsius, and the dew point in Celsius. So what is the average rate of change of the altitude with respect to time? So we got, so we have here 650 minus 360, but we're dealing with altitude. So 650's altitude is 4,900 minus 360 altitude is 2,900. So this is 2,000 over, right, 650 minus 360, 290. And then we do 2,000 divided by 290. And we get 6.89 feet per second. That's how fast, or the average rate that balloon is rising. Okay, what's the average rate of change of pressure with respect to time? So now we have time of 2750 minus 650, and we're talking about pressure. So the pressure at 2750 is 500. The pressure at 650 is 850. So this is going to be a negative 350 over 2100. So 350 divided by 2100 is a negative 0.16, repeating, right? So the pressure's dropping as the balloon's gaining altitude. Okay? So why is the rate in part A positive? Because the altitude is going up. Why is it negative in part B? Because the pressure is dropping. How is the temperature changing with respect to altitude from 0 to 360, right? So if you look at 0, it's 17. At 360 is negative 17, so it's dropping. This rate can be used using delta, so the change in temperature over the change in time. Okay? Okay, looking at 70. When a person wins the Dreams Comes True lottery of $1 million, they receive 50 immediately and 50,000 for 19 years. Okay, Dreams Come True deposits money into an account earning 12% annual interest, and in order to make the 50,000 yearly payments at this rate, they only need to deposit $368,000, right, to be zeroed out. What's the average rate of change over the 19 years? Okay, so that would be 19 years, so 19 minus year 0, right? And then our money at 19 years is 0 minus the 368 to 88.84. So let's do that, right? So we're going to take that number, that 368 to 88.84, and we're going to divide it by 19. Right, and you're going to get an average of negative 19,383.6. Right, that's how much money it's losing every year. Okay, if the payments are $50,000 a year, why is the balance in the savings account not decreasing by $50,000? Because it's gaining that 12% interest. So when it's gaining that interest, they're not actually losing the full $50,000 because they're gaining some of it back. Okay, C says, to do this, make a scatter plot of the data. You can do that on your calculator. Calculate the change in the investment account balance each year. So you could do this for each. So you're just doing slope for each one, right? Is the average rate of change per year increasing or decreasing, right? So the first one, it should be decreasing, right? So you can see the first year it only loses like $6,000, but at the end it loses $40,000 or $44,000. So the less money in the account, right, the less interest being gained, so the more it's actually losing to pay that person. Okay. Last one here. Stacy's typical exercise routine involves lifting weights, running, doing sit-ups. Her last workout, she chose a preset program. The data in the table represents various times and distances of the run. Between which two times is her average rate of change the second fastest? So here's what we're doing here. You're taking rates of change between each time, and then you're going to figure out not the fastest but the second fastest. So again, it's going to look like this, right? It's going to look like a ton of rates of change for each one of these, and then you would just go, okay, which one's the fastest? That one? Well, then this one is the second fastest, right? So that's what you're doing there. That would be a good practice problem for you to do on your own, but this is lesson 721.